Hello again, and welcome to The First Layer, the show that explores the world of 3D printing. Today I just want to do a real quick video here. With the release of Marlin 2.0.8, I have to go and migrate my configuration, so I thought I'd bring you guys along for the ride of what I do. So you'll see on screen here, the program I primarily like to go to is called WinMerge. It's a free program you can download for Windows. I believe there are Mac equivalents out there, but unfortunately I only work within the Windows space. So the reason I use this program is because it gives us a nice visual side-by-side of our code, of the old code and the new code, so we can actually see not only what we have changed, but also what has changed within the new Marlin version. Maybe there's a new feature that we didn't read on the GitHub notes, etc., etc. So you'll see here on my screen, I've got my first file as my existing configuration for my CR10. We're going to start with the configuration.h, and then we will move on to the configuration advanced.h. Our second file here is our newly extracted configuration.h, and you'll see one thing I like to do with my Marlin revisions for certain machines is I like to date track the date that I'm building that code, so I kind of have a go-by to remember what I'm working with here. So we can see, even though I've modified this one a few times, the initial date was January 23rd of this year, and the new one is May 1st here. So we're going to go ahead and set up our first file to be our initial one and our second file to be the new one. Now, just for a good sake here, I've marked our initial one as read-only just so that we don't accidentally make a code change and apply the defaults back to our old config, but I have made this one as writable, so we can actually make edits to the file as we're editing. So with that selected, we're going to go ahead and hit the compare button here. And almost instantaneously we get this two-pane layout. So we've got our existing config on the left and our new 2.0.8 on the right. Now all this color on the left actually indicates deletions, additions, and changes. So you can see there's a lot of code changes out here, and as we scroll through, we're going to figure out what the difference is between our new versions based off these highlights. So as we scroll down, one nice thing is actually both panes will scroll at the same time, and anything that's different is highlighted in yellow in this case. So we can see defined configuration H version is 20007 here, and it's 20008 over here. Now in some versions of Marlin, I have been able to get away with just changing this version here from 7 to 8, or in previous versions 6 to 7, and it will compile. But it's not a good practice, because then if the code changes or if there's a new feature, you may miss out on it by not adding it in here. So it's always a good idea to start with a fresh copy of the config and compare back and forth. Now as we scroll down here, we're going to see, I believe there is some verbiage changes here. So we can see on the old version it was, here are some standard links for getting your machine calibrated, and then here are some useful links, and now it's got better things for example configs. This is why you want to upgrade, because sometimes these links can be quite valuable. But what's nice about this here, and what I want to focus on, is we can accept these differences because this is just comments, and we identify comments with the /stars or the double slashes here. So if we keep scrolling down, we can see what's changed. So in 2.8, we've actually added there's a new version, or a new definition of your printer. Instead of just calling it a Delta printer, it can now be a Delta/Skara/Tpara. Now I haven't worked with the Tparas at all, I don't know much about them, but I'm going to assume it's just a different motion vector using the 3 arms there. So if you do have one of those machines, you can go ahead and play with that. Now what I wanted to show you here is the reason we use these comparison tools is because it will attempt to align the rest of the lines even if there's additions or deletions. So we can see here this extra gray space was added in so that our line number of our 2.0.7 for the next variable is actually also present at the same visual level, even though it's actually on a different line number. So what we're going to do here is, for example, here we've got our config author is changed from my customized one back to the defaults. So if we go over and copy and paste that over to this one, now you're going to see right away that this color changes and say, hey, now it matches. So we know that line has been taken care of. And this is the fastest way to quickly upgrade your Marlin, because you're just going to scroll through until you see line changes and make sure that items like serial port is -1 for this board, serial port 2 is 6 for this board. This is an SKR Pro. And items like this, it looks like they support up to 7 serial ports, and I think there's just a little... Okay, so they've added an Ethernet code functionality here. So let's keep moving on here and plow through a bunch of these changes. And this is why it's easy again. We can take the SKR board, and now it's the SKR Pro. my machine. I like to call it Spicy Printer. Don't ask why. And we're going to go ahead and change that to Spicy Printer. And you can see just by flying through this, we can quickly go and adapt all of our previous presets over and make sure, you know, that we've commented and uncommented things out. So there's a lot of code here that you can just skip through because nothing's changed. Power supply, we don't have power supply code on this one. Thermal settings. This is one people always forget, and you can see they've added some additional notes about the PT100s, which is very good to know about. Okay, so here we've got temp sensor for a hot end's actually 5. Our bed is actually a 1. And then take a look at this. There's a new temp sensor for a cooler. So this is the evolving part of Marlin where you can add more and more controllable fans to control your environment. Our previous biggest one was the addition of the chamber, but now you also have a cooling control system. So we'll dig into that and see if there's a value for it in the future. But for now, since we're not using that many thermistor inputs, we'll just leave it at 0 to be disabled. Dummy thermistor value, I believe, oh, it was just an addition of a space. So it's just for code organization. So we don't have to change that. All of this is commented out. So now we can take a look at the temp sensor redundancy time. It looks like they've changed a few of these parameters and kind of moved them over here. But they also have, again, this new chamber residency time. This is all for thermal protection. So let's just keep going past these. Max temp. This is a big one for my hot end. We can actually go hotter than the standard 275, and we are not running the chamber stuff. Thermal overshoot. That's pretty cool. This is a new setting here. Let's take a look at this. During heat up and printing, the temperature can often overshoot the target by many degrees, especially before PID tuning. Setting the target temperature too close to max temp guarantees a max temp shutdown. Oh, okay. So this has exposed the setting that we've always questioned. So when I set it to 320 above, I can only bring the hot end up to 305. And you may have noticed this with Marlin. If it's at 275, your max temperature is 260. Well, now they've exposed the setting for how much overshoot protection you want to have in the code. So by default, the bed, whatever your maximum bed temperature is, you can only go up to a maximum of 10 degrees below the max temp above. Hot end overshoot is 15 degrees, so 320 means 305, and the cooler has a set point 2. I wouldn't recommend changing these, just in my experience, because as noted in there, you can trigger a max temp if it does bounce over if you haven't PID tuned. So I would suggest always bumping up your heater max temp to compensate for that. Okay, let's go down through our PID settings. So on the original, I did like to have PID temp bed on for temperature control, max bed power. I'm actually changing this back to be full power. I had some concerns about power drop before. And let's copy over all of our tuning parameters. So a 1 and 114.4. Chamber, again, we're not running the chamber code, so we're just going to go ahead and skip past that. Extrusion minimum temperature. Now, this usually at 170 is fine, but I do find I can run some filaments that get a little cooler, so I'll put that in there. Thermal protection cooler is new. Most of this is going to be with that thermal protection cooler, but this is where we start to get to the printer-specific settings of inverting end stops. So we want to go through and make sure it matches, otherwise your steppers may go the wrong direction. So stepper drivers, we can see here we have 2209s. And today I'm actually changing the closed loop stepper off this back to a 2209 as well. So we're going to go ahead and transfer that over. And stop noise thresholds are the same. Now I do have a different extruder setup now, so we're going to go and it's about 445 if I recall. And the max feed rates, I did back them off a little bit there, but I think for now we will leave these at default and see how it responds. Default max acceleration, this one is always very important because 3000 is far too high for any kind of bed slinger design unless you have something really dialed in there. Okay, scrolling past that, default acceleration. I just like to set everything to about 500. It may be a little more conservative and your machine can probably go faster, but this is kind of my go-to values for anything for a CR10 and below for size. Okay, so now you can see we changed the jerk at one point from 10 to 8, but I'm not even using classic jerk, so I'm just going to go ahead and leave them at 10. Default E-jerk, we did bump it up for some values with linear advanced to try, but I'm going to change this to about, let's change this up to 8 and make it nice and clean. And then our junction deviation factor, we will talk about junction deviation in the future, but for my hot end, it likes about 0.04. Okay, scrolling on, use end stop pin, define manual probe start. That was just a line that I added in, or I guess they deleted it there, but we don't even need it because it's all commented out. Okay, so we are going to have our BL touch. Okay, so let's take a look at this X and Y offset. It looks like there's a lot of changes in here, and this is one of the big changes that's going to be coming up here in Marlin 2.0.8 is the Z probe alignment tool. And we're going to give that a go today, but we're going to start off with our values. Now, I actually moved the probe from one side of my nozzle to the other, and since it was perfect equal distance, it actually went from negative to positive. So based off my latest settings on the machine, they're actually going to be at these, and we're going to start with this and see how close it is. Now, probing margin, I usually like to set this around 50 because that covers your entire boundaries of your bed and makes sure that your nozzle and your probe is within those boundaries. So we're going to keep that at 50 this time. We're actually going to move these a little closer to the... we're going to basically allow it to be a little more inset into the bed just to protect it this time as we've moved the location. So probe activation switch, tear probes, I'm not too familiar with these, but I've seen them on a few printers where it drops down the end stop, but there are now identical or unique settings within the firmware for that. But we're just going to, again, pass this. If you do have those probes, let us know in the comments below, and we'll see if we can get a hold of one. Okay, so now this is a big one that you have to understand what this point does. Z probe low point basically says if the probe is lower than a certain distance, then to fail the bed leveling and say it's too unbalanced. So a lot of the times I'll see with people where they'll say, oh, my bed leveling data didn't actually commit. But what had actually happened was one of the probe points was below about 2 millimeters, and because of that, it basically threw out the bed leveling data, but it continues to print. There's no halt command on major failure for that. So I always set this a little bit higher, knowing very well that it will allow the printer to accept those set points, but if they're really out, weird things will happen. So just be aware that this is a good one to play with, but you could break something. Okay, now the next one, Z-min probe repeatability test. This is a must-have from now on because this will tell you if your probe's accuracy is out the window. And we will be showcasing this in the future, but please enable this feature if you have room in your firmware for it. Okay, so down here looks like they've added a few more settings for probing heaters. We can kind of jump through that. Now, invert Z direction, true. Again, we don't want it to go backwards. No motion before homing. Oh, I don't want that setting. Okay. Unknown Z rays. Most of this is probably fine to leave at the defaults. It's just a structure change here. Okay, so now we're on to our bed changes. 310, 310, and max is 400. Software end stops. Okay, so this one I do like to add in because occasionally you do want to move your nozzle below the 0. And that's where this menu item is nice because then you can hot disable or re-enable the soft end stops without recompiling your firmware. Okay, now let's look at our filament runout sensor settings here. So I'm using the Triangle Lab filament runout sensor here, and these were my settings that worked perfectly for it. So filament runout state is going to be high. We only have one runout sensor. We are not actually pulling up, we are going to be pulling down the voltage line. And I commented this out because when I changed my motherboard, this was no longer the correct pin. So you can go and override the filament detection pin for your board if you're having troubles. That's why I chose to leave that in there. And I think I'm actually going to transfer this over because this could be valuable if I do have problems with the board in the future. But we're going to leave it commented out. Okay, so scrolling down, it looks like they've added up to 8 filament runout sensor options, which is pretty cool, but we only have 1, so let's just leave that for now. Okay, go down to bed leveling. This is where we're probably going to have a lot of setting changes from the defaults. We want to restore leveling after G28, and this is a new one, enable leveling after G28. Let's put that one on there. Okay, auto leveling, ooh. Okay, so this is also a very valuable one that's new that I'd like to play with here. So preheat before leveling. The nozzle is fine, just if you want to preheat it, but I want my bed up to temperature because as you heat your bed, the properties of the bed can change. So I've naturally been preheating my bed before running my G29. I think this is going to be a great feature, so I'm going to turn that on. Now, just as a good housekeeping habit here, you'll notice I've been chunking through, but I haven't been saving, and you can tell because there's an asterisk at the top right up here by my A drive. So I'm going to hit Control-S just to save it. Just get into a good habit of saving things because things can go very wrong when you lose your power. Okay, perfect. So this, oh my gosh, I'm so happy to see this setting because for whatever reason the firmware has not had it up until now. The default fade height. So anytime you enable fade height, it defaults to 0, which means no fade. But you have to go and type it in every time. Now we actually have a default. So 10 is a great number to start out with. Okay, so looking at these are mostly the same. I have a feeling the verbiage after the comments changed a bit, which is why they're identified. Let's leave them just as is because we're not even using mesh validation right now. Okay, we're going to bump up our max grid points. We're going to extrapolate beyond the grid, especially with us being so inset. We're going to enable bilinear subdivision, and I've got tons of memory on this board, so let's actually go up to 3. Okay, so unified bed leveling. We're not using UBI, so we're going to skip past that for now. So, level bed corners, use probe. You know what? I'm going to go ahead and enable this feature. And we're going to go ahead and enable it and just see what it gives us for options. That's pretty cool. Okay, Z-Safe homing. That's a must-have for BL touches or any ABLs. Homing feed rate. Okay, so they've gone ahead and unified it into an array of values, 50, 50, and 4. So sometimes your axes can move faster, so we can change this. Let's just leave that as is. Okay, now yes, we do need EEPROM settings. And yes, we want it to auto-init and erase our EEPROM when we flash this firmware, just to make sure there's no incompatibilities there. Okay, preheat constants. Now, a lot of people may not know this. This section here is where you can set your preheat temperatures. So, depending on your material printing, I always like to have my bed at 60. Chamber, since we don't have one, I'll set it to 0 just for good practice. And then for the ABS, I don't print ABS on this machine. So what I like to do sometimes is I like to change the ABS over to PETG and set the thresh point at 240 and let's say 90 degrees Celsius to start with. So by doing this, you can have a PLA and a PETG preheat, or if there's another material, let's say with Matter 3D filament, I like to run it a bit warmer, you could call it Matter 3D PLA, and then have a separate preheat set point for that. So myself, yeah, I prefer to have this as PETG, but you can have some preheat presets based off your filament type. Okay, we are going to enable the nozzle park, and this one always catches me off guard. I actually like to have my nozzle parking position at the front of the bed. So I change this to Y-min plus 10 and X-min plus 10. And they lift at 20 millimeters for whatever reason. I only like to go up about 5 millimeters just to save some time there. Okay, minimum hot end temperature for cleaning. Yeah, that's probably a good one just to leave on default. Print counter. So there's some additional settings for the print counter. We're not going to use that for now. There are more languages. I don't even know what test is there. Okay, so it looks like they've gotten rid of the SPI speed settings underneath SD card support, but that's fine because we didn't have any of it enabled. We're going to go down to individual axis homing. I like to have that one on. And there's a couple of new displays it looks like that were added in for support. So we're going to fly down until we find our RepRap full discount full graphic smart controller. It's a mouthful. Alright, scrolling down, looks like there's some alt wiring options for the ANET full graphics screens, MKS OLEDs, the FISECT, I'll figure out how to pronounce that one of these days, the Digus, Nexcon. These are all just new graphic options here, new comments. We're probably not going to be touching any of this, so this is probably going to take us pretty close to the end here of this document. just some NeoPixel settings, which I don't use. So when we're all done with that, we can go ahead and save that file. Now we're going to move on to our next file, which would be the configuration.h. So we're going to do a new, go open, browse. I'm going to select the configuration.h, make sure that's the 2.072, mark it as read-only. We're going to go to this one here, and we're going to make it in the 2.08 folder, and take the config-advanced.h and leave that one as writable. And then we're just going to do the exact same thing we did with our last one here. So starting at the top, we're actually going to go through and find what changed. So the version number, additional temperature sensors. We don't have a heated chamber, so we don't have to worry about that. We're just going to go down until we find, oh, laser cooler. Okay, so maybe that's what the new cooler setting is for cooling the lasers. Okay, now this is where we get into our controls for the hot end, for our thermal runaway detection there, and based off knowing my hot ends, I like to see a different adjustment period here. So we're going to bump these up to 40 seconds, and I'm actually going to drop this to 1 just because I've had a few issues with my fan recently overcooling the hot end. So we're going to leave at 40 in 1 and 60 in 1. Thermal bed period. This one for the bed for sure. It can take some time to heat up, so I do bump that one up. And this is just all through experience. If you're not sure what these settings actually do not modify them from the defaults. Okay, so there's PID fan scaling, which again we are not using on this build. High temperature thermistor support, we're not doing any of that stuff. And you'll see there's a lot of blank areas, but this is why it's so fast to drill through it. So I'm actually going to comment out this one because of my board configuration. I actually use a different pin for my fans. Cooler fan auto temperature, 18 degrees. And we can see here, this is where my auto fan setup it comes in. So at 50 degrees, it turns on the part cooling fan at full speed. Just for sake of repeatability, I'm actually going to drop this down to 35 just so that fans runs a little bit more often here. Case lights, we don't have any of those. We don't have independently driven steppers on the Z, even though it's a nice thing to have. There's some IDEX items in here. Home Z first is a new option, but I would not mess with that. Okay, so BL Touch delay. I do like to have this one on just to give it an extra time to settle itself out when I go and probe the bed. Okay, so we've got the BL Touch LCD voltage menu. I like to have this one here, but I wouldn't recommend users have it just in case something can go bad. So assisted tramming is one I haven't played with yet, but I have room in my memory, so I'm going to go ahead and drop that right in there. Report tramming millimeters, assisted tramming. We're going to actually add the wizard. And I think we're fine without the millimeters for now. Screw threads, if you take a look at this, M4. That's what's under our bed, and those are 40 turns. Stepper deactivate time. Now my preference here is I don't like to ever let the steppers deactivate, so I set that to 0. And I usually just set these all to false anyways, just to cover our bases, even though it's covered by the setting being set to 0. Okay, so minimum time that segment needs to take before the buffer gets emptied. I'm going to return this one back to normal and see how it works. And we're going to re-enable slowdown here. Okay, now this is a nice setting I do like to have on, which is the frequency limit. And if you set this to a nice value, it starts out as low as 10, but I find it slows my machine down too much. This just prevents your machine from oscillating at high frequency rates. So a 10 hertz means that 10 times a second it can change direction. And any faster than that, it will slow down. So yeah, leave that one enabled at about 10 hertz, and then if you find you're having issues, you can actually increase it through the LCD menu. Okay, we don't have core kinematics for this. We're going to scroll down. Adaptive step smoothing, that's kind of a no-brainer these days to have enabled. We don't have a digipot. We don't have an Alta panel. Sound menu. Okay, if has display, it looks like they've added a bunch more settings here, so we're not going to really change any of these. I'm going to go down to the... Okay, so this is where they move the SPI speed to, but we're not going to change any of that. SD card read only. I do like to set that one because we don't generally write to the SD card from the printer. Okay, we don't. We do want it to auto start. Continue after power loss. Let's throw on the power loss recovery this time and see if it works. Okay, I do like the SD cards sorted alphabetically. Long file name, 100% should be in there. Scroll should be in there. And I do like to have the heater stay warm when I'm having issues so I don't have to reheat the printer. Okay, we're going to skip the USB stuff for now. This one is important for the SKR boards to define the location of your SD card, otherwise it may not show up. I do like to show the print percentage on the screen. We're not going to change any of the animations. Not going to change any of that. Any cubic chyron displays, we don't have one of those, luckily. What I'm trying to get down to here is things like this. Baby stepping. This is my area. Okay, so we are going to integrate the baby stepping with the ISR. We're going to make it always available just to figure out our exact offsets, even though we're not printing. I do want to have it as millimeters, and the reason for that is because then it's a lot cleaner. And then what I set it to usually is a multiplier of our Z steps. So 0.0025 is our effective height increase when we're doing microsteps at a go. So this was a little aggressive last time I put these values in there. I think I'm going to bump this up to about 0.01. And, you know, you can make this a little bit lower, but ideally we're not supposed to be making drastic changes like that to the baby stepping. We want the double click to Z baby step. We want it to show the total number of baby steps so we can actually adjust our probe offsets if it's wrong. We're going to enable our linear advance. I think I'd like this actually closer to 0.08 to start with. So previously I set these probing margins. I'm not going to use this time because I want to have the inset proper. This is a nice one, so if it does fail your probing, it will retry just in case something acted up with your probe. I haven't used this feature yet, but I've enabled it. Millimeters per arc segment. I'm going to try the defaults this time around and see how it runs. Bezier core. Again, this might come in the future, but for now I will drop it in. Direct stepping, I would have it enabled, but we can't because of the nature of Marlin right now. It doesn't support linear advance, unfortunately. So we're going to go ahead and actually leave all these commented out this time and see how they perform. But I am going to increase my SD card buffer size for all the blocks for reading code. Okay, advanced okay. We all put that one in there. Serial float precision. I do like to have this one to just reduce the serial data. We don't have firmware retract. We don't have a tool sensor. Advanced pause, we do want this enabled. And our nozzle park timeout, I believe this is related to the cooldown period. I do like to set this longer so it doesn't cool down after waiting too long for you to change out your filament. Okay, so the TMC 2600s, we don't have any of these, so we're actually going to jump ahead to the Trinamic section. Okay, so hold multiplier. You know what, we're going to try it at 0.5 this time. I like to have it a bit higher. Microsteps is 16. Chain position, -1. Oh, and you can choose to interpolate different axes. That's kind of nice. So what I'm going to do is I'm going to leave all of the interpolations true this time around. But let's take a look at these tuning values. Let's keep that at 800. Let's actually set the Y up to, I do agree, 1000 because I do have a higher quality stepper here. The Y interpolate's always on. Microsteps is going to be the same setting for the previous. 800, let's set this to 12. Just give it a little extra power there for the two steppers. Z3, Z4, E0. Okay, E0 will be 800 again this time here. Let's get through all these different extruders they've added in. Chip selects, nothing like that. Okay, they've commented out. So let's go ahead because they're 22 and 9s. Let's keep these the same. software driver we don't need for this particular board. So you can define chopper timing for each of the axes, but I'm going to change the default. Actually, sorry, this is a 12-volt machine. We're going to leave that there. Monitor, I do want this on. Step down, we won't make it as drastic. We'll make it 25 milliamps. And stop on error if it's having a big problem. Okay, let's scroll past this. Square wave, always good for trinamics. And TMC debug, great if you have the storage space. Okay, we'll step through the L's there. We don't have any of those. So there's an air evacuation feature. So it seems like Marlin's going CNC route. That's kind of cool. Laser power inline. We'll leave all that because that's all lasers. Synchronized lasers. Monitor power current. Again, that's all defaults. Details. Let's go ahead and enable that. So that just in case there is something that comes in quotes, that will be good. Okay, so I did have some user code here. So what I'm going to do is I'm just going to copy everything I had in this body here. And we're just custom menu main. Oh, okay, so these are all under different menus now. Okay, so we have the option of writing multiple menu ones now. So I just written some arc motion tests and stuff like that. I'm just going to leave those for now because I want to see what this new stuff is. I'm going to leave that in there for the future here. Okay, this is one, again, I haven't used yet, but I do want to have it available. We don't have the mechanical gantry calibration enabled. Nano DLP Z-Sync. Oh, cool. So maybe they're looking at Nano DLP. We're not going to touch that. Prusa multi-material. We don't have that. Prusa MM2. Debugging pins. And Porous mode decoding. So that's all we need to change in these two files. So we'll make sure they're all saved up. And then what we're going to do over here is we're going to bring up Visual Studio Code here. And see if the translation worked. And we can see we have the previous items we were working on here. So we're going to go ahead and reopen the folder. Go into here, select the folder. And we're going to go to the Marlin Auto Builder that we have installed. If you don't have this installed, Auto Build Marlin, it's a great plugin, and it's definitely evolved from the previous video when I covered it here. So click on Show ABM Panel. Okay, so we got our auto build panel up here, and we can see here that based off my configuration, machine name, Cartesian, with heated bed, single extruder, it read all my configuration nicely. So we're going to go ahead and build for the Big Tree SKR Pro, so we're just going to go ahead and hit build. If we scroll down to the bottom here, we can watch it build its code. Okay, so we can see we have some errors here, and based off our translation, if we scroll up, it says here, only enable restore leveling after G28 or enable leveling after G28, but not both. And you'll see a lot of repeated these, so whenever you have an error in Marlin, you're going to want to scroll up to the first error you see. So let's go ahead over to our configuration. And this is cool too about WinMerge, it creates backup files for your changes, so you can see what you changed in there too. So we're going to look up restore leveling after G28. Or to always enable. Okay, so this is great. So then when you home, it's not going to erase your bed leveling data. This is huge. So let's go ahead and get rid of the restore one, and we're only going to use enable. And now we're going to go back to our auto build Marlin and build it again. Okay, so here's a good one for something that I clearly overlooked was the power loss recovery. Your SD card can't be read-only because it has to read something there. So let's find SD card read-only. Okay, it's not in config.h, so it must be under config-advanced.h. Okay, so SD card read-only. Let's get rid of that. Done. Next one. Tramming point is not reachable. Okay, so let's go ahead and find this while we're here. Tramming point. Okay, so this is within the offsets. So for now, I'm going to turn off assisted tramming because I have my own manual tool in place here. Let's go ahead and build it. You'll see a lot of these are sanity checks to make sure you're not an idiot, basically. And as you can see, it's not abnormal to find a bunch of errors throughout your code. It's just a matter that it takes time. You got to step through them one by one. So we can see here, level bed corners, yes, that inset is indeed not high enough, because our probe is as far out as minus 32 or plus 32. All right, let's go again. And just like that, we've got ourselves some new source code. That's the way, I like it. And with that, that's all it took to migrate our version of Marlin over to 2.0.8. And this will apply for most versions of Marlin, as long as you're not coming from 1.1.9, as there's just so many significant code changes. It's really hard to migrate between the two. Not impossible, just tricky. But if you do have a newer version of Marlin, or your vendor, for instance, has given you a bug fix version or a very old version that you just kind of want to bring forward and no one else has done it, it's just as easy as using this software. And we can see we went through the entire config.h and configuration.advanced.h in about 30 minutes or so, including all of our bug fixes. So hopefully this gets you right back on path with Marlin, gets you all up to date, and gives you the opportunity to try all those new features. Let me know in the comments below what version of Marlin you're using, if you're running on the bleeding edge of 2.0.8, or maybe you're sticking with an old version that just still works for you. But until then, remember that the first layer is always your foundation to a great print, and we'll see you next time.